This short video will demonstrate how to use manipulatives to learn about solving linear equations. Suppose you had the following materials in front of you, and you were told that each side has the same number of chips. A natural question to ask would be, how many chips are in the cup? To figure that out, we might remove 3 chips from each side. So we see that the cup must contain 4 chips. Let's look at another more visually complex problem. Suppose you had the following materials in front of you, and you were told that each side has the same number of chips, and each cup contains the same amount of chips. Could you determine how many chips are in each cup? We might simplify the scene a little bit by removing a cup from each side. Then we could remove the same number of chips from each side. This helps us to see that each cup must contain 3 chips. Looking back, we can see that for our original set of materials, that 3 chips in a cup does indeed mean that each side has the same number of chips. We will continue to make our system more complex. Let's define the yellow chips to be positive in value, and red chips will represent negative values. This means that when we pair a yellow and a red, we get a resulting value of 0. With this new twist, suppose you have the following materials in front of you, and you are told that each side has the same value of chips, and that cups contain identical values. Our question becomes, what is the cup's value? One approach to take would be to add a 0 pair, not changing the value to the left side. Now we can simplify the scene by removing 3 yellows from each side, leaving a red on the left and the cup on the right. Another approach could be to add 3 reds to each side. Now we have a lot of 0 pairs, and they can be pulled away because they contribute nothing to the value on either side. Again, we see that 1 red remains on the left, meaning that the cup must have a value of -1. Now that we've built a working model for most linear equations, we have some follow-up questions, including how will you translate the system to using algebraic squiggles? Then you have to consider how will you represent the opposite of x. Once you have a handle on these questions, create some cups and chips problems for others to solve. Use a visual representation for these problems, not an algebraic one.